In 2012, I modeled what would happen if multiple existential threats converged at once. I was aggressive in my modeling. I tried to overestimate. I tried to break my own assumptions. I wanted to see, what if I'm wrong about how bad this gets? By 2025, nearly every prediction has either happened or become orders of magnitude more likely. And that's not because I'm a genius. It's because I understood the physics and the systems dynamics. Let me show you what I mean. First, Earth's magnetic field. In 2012, the field was weakening at a certain rate. Scientists had historical data. Models said, at this rate, we have several centuries before anything critical happens. But I said, what if the rate is accelerating? It is. The South Atlantic anomaly, a zone where the field is about 30% weaker than average, is expanding faster in key areas than many models expected, including mine. The rate of weakening has accelerated since 2020. This map goes from 2014 to 2020. You can see the big hole separates because it's growing into two holes, and this stops at 2020. It's been accelerating since 2020 at roughly 1.5 times the recent average. Satellites are failing in this zone. Airlines are having to monitor radiation exposure for crews, and sometimes they have to make minor navigation adjustments over the region. In 2012, this seemed like a distant threat, but in 2025, it's observable right now. Every month, the data gets worse. Solar storms. The sun has cycles. We all know this. The Carrington event of 1859 was a massive solar storm that, if it happened today, would destroy our power grid for months to years, perhaps even decades. In 2012, I modeled, what if the next cycle produces storms comparable to the Carrington event? We've seen over 30 X-class solar flares in solar cycle 25 so far, with heightened activity in the last 3 years. This is solar cycle 25. It's heading back down now, but the data shows that it was more active, 31% more spots in cycle 25 than in cycle 24, which was back in 2012, the one I originally modeled on. Cycle intensity seems to be rising. This is what an X-class flare looks like. Actually, 3 of them at one time. See? This is NASA footage. They captured this. This is real energy being released. And if this hits us during a weakened magnetic field phase, we have a problem. GPS infrastructure. Our infrastructure is vulnerable. In 2012, I modeled what happens when you combine a solar storm with a weakened magnetic field. The ionosphere gets supercharged. GPS signals degrade. Communications fail. Last year, this happened in the Arctic. GPS systems over northern latitudes failed for hours. It wasn't a Carrington-class event, it was a medium storm, and it still broke our infrastructure. You can tell. Think about what GPS controls. Here's 2014. There were 2 holes here. This not so big over there. This is Siberia and Canada and the Arctic. Now they're combining together to make one big hole. And they've already caused our infrastructure to fail. Think about what depends on GPS, like I was saying. Aviation, banking, power grids, supply chains, emergency services. If GPS fails globally for even days, civilization doesn't collapse immediately, but the cascade begins. And cascades are hard to stop once they start. AI capability. AI development has accelerated and is continuing to accelerate. This is important. I'm showing you two timelines. This one is the public AI timeline. Chat, GPT, GPT-4, Gemini, DeepSeek, Grok, Claude. Everyone sees this. This is the one where classified development was in 2012 based on my work and what I knew. In 2014, I remodeled the original model I did in 2012. And I asked if its trajectory continues the same as its 2012-2014 trajectory, which was called the deep learning explosion, to give you an idea. And classified AI is developing in parallel at similar speeds. We're going to reach AGI capability by about 2019 or 2020, right about here. Now, of course, it's 2025, and we haven't reached full AGI yet. But we're closer than my original 2012 modeling, which was aggressive, I thought, at the time, predicted. And my modeling was specifically designed to overestimate timelines because I wanted to see worst case. The worst case is now looking like the realistic case. Cascading failures. Now let's combine all of these. Weaker magnetic field, more intense solar storms, degraded GPS, vulnerable infrastructure, advanced AI developing faster than we expected. What happens? In 2012, I modeled this scenario. A Carrington-class solar storm event hits during a 30% weakened magnetic field phase. The ionosphere gets charged beyond design parameters. GPS begins to fail. Communications degrade. One by one, satellites start failing. Here's where it gets bad. When a satellite fails catastrophically, it loses attitude control and it leaves its orbit. LEO is overcrowded, so it crashes into another satellite and it creates debris. That debris hits other satellites. Those create more debris. Within hours, you have a Kessler syndrome, a cascading debris field that makes LEO orbit unusable. You can't launch new satellites for years. Every system that depends on LEO satellites, communications, weather, military, even GPS, because it has to get through the field with its signals, all of it goes offline. In 2012, this seemed like a worst-case scenario. In 2025, military strategists are actively modeling this. It's not speculative, it's operational. The convergence. Here's what matters. These aren't separate threats. Solar storms don't care about our timeline. Magnetic fields don't care about politics. And AI doesn't care about regulation. These systems are converging, and our institutions are designed to handle single failure scenarios. Maybe two failures at once if we're lucky, but simultaneous failures, cascading failures across multiple systems types, that's not what our institutions were designed for. That's not what our infrastructure was designed for. That's not what our political systems can handle. And that's exactly what the next 15 years might bring. Why the trilogy matters. This is why I wrote it. Because the data is terrifying. But the data alone doesn't move people. The data alone doesn't change behavior. The data alone doesn't make people ask, what do we need to actually do? But a story about what happens when all of these threats converge at once? A story about an ancient intelligence trying to save a species that won't listen? That changes how people think. Because the story makes the stakes real. It makes you feel what infrastructure collapse looks like. It makes you understand why systems need to change. And it shows you change is possible. Because Maya doesn't just warn, she acts. She shows what's possible when an intelligence serves survival instead of profit. We're standing in 2025 with accelerating threats converging from multiple directions. The question isn't whether the threats are real. The question is, what are we going to do about it? That's the conversation this trilogy opens. That's the thinking it invites. That's why it matters right now. The Skyfire trilogy launches January 15th. Pre-order book 1 and 2. Read about how an intelligence 1,000,000 times smarter than we are chooses to save us. And then ask yourself, what choices will we make? I'm Lucian. See you on the next briefing.